running up until 12. So we want to give you some kind of like key technical knowledge, as well as giving you information on what's relevant to HS2 and what HS2 are doing in terms of carbon. But the main kind of themes of the session are going to be around net zero and science-based targets, as I said. So we're going to talk a bit about the science behind science-based targets, and some of the key concepts that you need to carry out the science-based target and go through that process, which include things like scopes, boundaries, and net zero. Then we're going to look a bit more at carbon reduction as well. So once you've got a science-based target, how do you actually get there? And then, yeah, we'll bring in Daryl again in the second half of the session to give us a bit of a case study about what's happening at Euston. We'll have some time at the end for questions as well and throughout. So one more thing to mention is that we'll probably take a break at about 11 so that you can stretch your legs and get a cup of tea and stuff. Righty-ho. I've just seen there's something in the chat, but oh, okay, the session will be recorded. Cool. So you can pass it on to colleagues and all that kind of thing. I think the next slide is getting ready for Mentimeter, so I'm just going to skip that because I'll actually just do that when we come to the polling. We'll be using Mentimeter as a polling tool like later on in the session, so just to be aware, if you have a smartphone, we'll be using that, and if you don't have a smartphone, we'll use your browser to kind of access that polling. But for now, I'll hand over to Daryl to give you an overview of HS2 strategy.
Thanks, Naomi. Hi, my name's Daryl Hennihan. As I said, I'm an environment manager. I work on the Euston Station contract of High Speed 2. I should say that I'm not a carbon specialist, but I do have quite a lot to do with sustainability and carbon for my day job. If you could go to the next slide, please, Naomi. So this is kind of the generic sort of aims of High Speed 2. So it's advertised being all about the 3 C's, so capacity, carbon, and better connectivity. So carbon reduction, it's not a new requirement for HS2, it's fundamental to our purpose. It's seen as forming a critical part of the net zero transport system. So it will deliver zero carbon journeys to hundreds of thousands of people every day. And it will contribute to the decarbonisation of the wider transport strategy. So it will allow us to move passengers off the existing rail network and put freight onto the existing rail network, moving it off the roads. But it's not just about the operational benefits, it's also about how we construct HS2 as well. Next slide, please. So this is kind of the more specific aims. So you've possibly heard a bit about this. So it's looking at the goals of HS2 to act as a catalyst for growth, the capacity and connectivity, value for money, customer experience. I won't go through all of them, but carbon forms a vital part of our strategic objectives is the point of this slide. Next slide, please. So in order to reduce carbon footprint, we need to first understand where our whole life carbon impacts are for the program. So this is what the carbon footprint for phase 1 of HS2, so that's the London to Birmingham route, would look like if we simply adopted the current UK industry, construction industry practice. So when we measure carbon, we look at the whole life carbon impact of our assets. So that's over a 120-year design life. So that includes construction and the operation of the railway. So the whole life carbon footprint would be approximately 14.5 million tonnes of carbon dioxide equivalent emission. And almost 50%, as you can see on the slide there, is associated with the extraction, processing, and manufacture of raw materials and construction products. Then a further 25%, so that's the transport and construction emissions on that slide, are associated with transport and construction. So all in all, approximately 75% of the construction emissions, of the carbon emissions are associated with the construction phase. And then you've got the kind of maintenance and operational energy on the right of the next slide, please. So this is the kind of carbon management strategy for the HS2 organization. So we're aiming to play a significant role in advancing and accelerating decarbonisation across construction and manufacturing industries in the UK. So the slide summarises the key components of our carbon management system. And that's been accredited by Lloyd's Register Quality Assurance and to the best practice standard for carbon management of PAS 2080. The accreditation recognises that we have the right processes and capabilities in place to deliver effective management of carbon emissions and to achieve carbon reductions. And our main works contractors are required to implement the same carbon management best practice. So they in turn will implement standards down through their supply chain, which is where I guess where many of you will come in. So it means that HS2 and our supply chain are working within a common carbon management framework. But reducing, sorry, I'm still going on the previous slide.
Sorry, I'll go back. I just lost
okay.
connection.
That's fine. So a key part of this is raising awareness to build the capability and motivate action to deliver lower carbon solutions. So as part of building capability, we've developed a program of carbon literacy training, which seeks to provide colleagues with the motivation and capability to reduce carbon emissions. That's a big driver within HS2 and also the supply chain. Can we go to the next slide, please? So these are some examples on phase one of things we're doing right now to reduce carbon. So the top left there is the Colne Valley Viaduct, which, as the name suggests, stretches across the Colne Valley. It's a very large structure. So we've worked with rail systems to reduce the size, the width of that viaduct, to obviously we maintain the safety and functionality of the viaducts, but we've also, in reducing the size, reduces obviously the amount of material we need to construct it. So we've cut the amount of embedded carbon by 28% relative to the baseline there. It also, so in reducing the amount of material, that also reduces the carbon emissions associated with the transport of that material as well. So that goes back to the earlier slide about where the carbon emissions are coming from. So obviously you reduce the amount of material, you reduce the carbon in creating that material and also transporting the material as well. And then beneath it is the Thames Valley Viaduct. So that's being delivered by EKFB. And also, so they've looked at using more up-to-date engineering techniques. So the design team simplified the structure of the viaduct. And so that allowed many of the major elements to be made off-site before being assembled on-site. So it's kind of being slotted together like a giant Lego set. And that cut the carbon footprint by about 66%. So again, it's reducing the amount of materials and also reducing the amount of transport of materials to the site. then the Curzon Street station. So they've looked at a number of measures, and that they've reduced the whole life carbon emissions by about 50%. So they've looked at, they've designed to achieve zero emissions from energy consumed to operate the building through heating, cooling, lighting, these LED lighting, solar panels, ground source heat pumps as well. And they've used fabricated timber soffit units, which are 27 times more carbon efficient than the steel comparators. The paving, they've looked at reducing the depth of that, which obviously reduces embodied carbon, and they're using 100% recycled steel content on the roof sections as well, and they'll be bolted together instead of welding. And then the other pictures on the site, on the slide, measures that we've taken on our construction sites across the route to reduce the emissions associated with construction. So whether it's using or trialing electric cranes, electric forklifts, or different types of generators. And the bottom right is a different type of pile, which is essentially hollow in the middle, again, reducing the amount of material used to construct. Next slide, please. Thank you. So as you can see, that the work to cut the carbon emissions is well underway on the HS2 project, and just kind of taking a step back and looking at our organizational processes. So we're a carbon literate organization, and since 2016, we've been working to halve the carbon footprint of phase one. There's substantial carbon reduction has already been achieved. So we're at about a 25% reduction across all of phase one as of March 2022. Next slide, please. But we need to go further. So bearing in mind that HS2 achieved royal assent in 2016, I think. So some of the targets that we've set, they were cutting edge at the time, I guess, but the time is moving on, and this area is moving very quickly as well. So we're doing a lot of work to kind of keep up and push further by developing our net zero carbon plan. So the main points is that we'll become a net zero carbon business. So that's looking at scope 1 and 2 emissions. So just HS2 itself by 2025. We'll deliver a zero carbon travel plan from day one of operation. So looking at the use of renewable energy, etc., to power the trains. And we'll achieve net zero carbon construction and operation by 2035. And so so as part of that, we'll be eliminating diesel on all of our construction sites by 2029. We'll be specifying and purchasing concrete and steel with half the production carbon emissions of the 2021 levels by 2030. And as I said, using 100% zero carbon electricity to power our train stations, depots, and infrastructure. Next slide, please. And this slide is just the kind of key action areas within our organization. So essentially, I think in summary, it's sort of building the awareness, motivating action, and building capability within both HS2 and our supply chain, using up-to-date tools, best practice, sharing lessons learned in the wider construction industry, and working with industry groups and peers, supply chain partners, etc., to make sure our efforts are aligned, that we're learning from each other, and also taking the most effective action to achieve these goals. Next slide, please. I think that's all that I needed to share on sort of the overarching HS2 strategy. This is just a slide of some quick links should you need to access them after this presentation. Thank you very much.
Thanks, Darryl. Does anybody have any questions for Darryl at this point about the HS2 side of things from a strategic perspective? Jude, you've got a hand up. Do you want to try to type your question or come on mic if you?
Happy enough to come on mic. Do you know, you said net zero by 2025. Does that mean that effectively everything we sort of put carbon in the atmosphere will do something that balances that to sort of counter it? Is that what that means?
Yeah, that's exactly right.
Okay.
And I should just specify that's only for HS2 as an organization, so that doesn't count for our supply chain. Obviously, there's a lot in that plan that will feed down to the supply chain, like using lower carbon concrete and steel, but there's quite a lot to go, quite a lot of progress to be made as a construction industry to develop viable alternatives at the scale that, of material that we're using, which is why that aim comes a little later in the process.
Sure. Okay. Thanks very much. Cheers.
Thanks, Jude. Daniel?
Yes. Hi. Thank you for the presentation. Just following on from that point. So when you say HS2 operations to be net zero by 2025, is that primarily just office activities then, and then any travel from your staff, given that most of the actual construction is obviously, as you said, within the supply chain?
Yeah, that's exactly right.
Okay.
But then the 2035 date, the net zero 2035, that's our so the operation of the railway and also the construction as well. And then that's why we have targets in there about sort of the 50% reduction in carbon emissions from steel and concrete by 2029, I think it is. So yeah.
Okay, that makes sense. Thank you.
Yeah.
Great. Any more questions or happy enough? Oh, Tessa.
Yeah.
Hello, yeah, sorry, I'm in a bit of a noisy office. It was just to ask what measuring tools you use. I appreciate we're getting onto the science-based stuff, but what measuring tool do you use to calculate the arriving at net zero figures?
Each kind of contractor uses a different tool, I think. Well, there's a couple of tools. So it's mainly one click or e-tool, I think the contractors use. So each contractor will use that to calculate their carbon baseline and then their progress against that baseline. And they'll obviously take inputs from each subcontractor that they use. So that's all cascaded through the supply chain. I think we're looking at moving to using e-tool across the piece, particularly in phase 2 of the construction and operation. But I think for the phase 1 contractors, I think I'm right in saying there's mainly use of one click and e-tool.
Thanks. And I think there was just a quick question in the chat there. What were the main challenges on the first diesel-free construction site in 2022? Are you able to answer that, Darryl? Are you aware of any issues?
Yeah, so I think, so what we've done as an organization is essentially badge up each kind of construction site. So we move from, there's, I think, 4 different categories. So kind of the best and then kind of dropping down. I think it's like diamond, gold, silver, and bronze or something or whatever. So I think the first construction site to be diesel free, they had to rely a lot on HVO. So vegetable oil, basically, which still has emissions associated with it. I think that's kind of the main challenge at the moment, is just getting the like through our supply chains, etc., just the availability of the technologies to make sure that we have diesel-free construction sites. So some of our construction sites are within urban areas, so it makes it easier to be powered by mains electricity. But many of our construction sites are in the countryside, a long way from any sort of mains power. So it's about trying to find, generators that are not powered by diesel, so hybrid generators or whatever, and plant as well that can be powered by electricity or alternate fuels. So we're really pushing hard as an organization, but I think at the moment it's just the availability of the alternate fuels and different products that is the main challenge.
Yeah, that makes sense. Okie doke. Thanks for those questions, and thanks Darryl for setting the scene there. It's really helpful. I'll get cracking on the sort of background knowledge to SBTs. So we'll kind of quickly whiz through just some of the basics around climate crisis and climate change, just to kind of get everyone up to speed. I'm well aware that many of you may already know this sort of scientific background. But in terms of the mechanisms behind climate change, the primary one would be the greenhouse gas effect. And one thing to note about the greenhouse gas effect is that it's a part of the Earth system without human intervention. It keeps Earth habitable for the life on Earth. The way that it works is by trapping solar radiation that comes into the Earth system. So heat that's absorbed from the sun gets re-radiated, and then the greenhouse gases in the atmosphere absorb some of the heat and then also re-radiate that themselves. And that just means that less heat escapes into space than would otherwise without any greenhouse gases. Then in terms of the kind of anthropogenic or human enhanced greenhouse effect, the way that's working is that additional greenhouse gases are being emitted into the atmosphere, and they are kind of providing a thicker blanket of heat trapping abilities for the Earth system. So less heat is escaping into space than would otherwise, and more is being retained. And we talked about heat here, but heat is also analogous with energy. So you don't just get warming, you also get increased storm intensity and other impacts that I'll mention in a sec. And the reason that we know that this is happening and that humans are causing climate change is through a number of different means, but in recent times we actually have observations of warming. So this is a fairly short-term timescale going back to the late 1900s, the Industrial Revolution. And this shows the warming trends that's happened since then. And around this time was when we started emitting greenhouse gases on a large scale. So where we're at now is about 1.1 degrees, 1.2 degrees above that pre-industrial baseline temperature. And the blue line here, so the red line is observations, and then the blue line is sort of modelling based on what we would predict the greenhouse gases that we put into the atmosphere to cause. But in terms of that 1.1 degree figure, that isn't spread homogeneously around the globe. So different regions of the globe will actually have warming in a particular season of on the order of, even up to 10, 20 degrees warmer than the average, especially if you're going up to polar regions. That's just because Earth is an extremely complex system. We don't even fully really know, we're not able to fully predict the impacts of this amount of warming at the moment because it's just so complex. So the impacts of climate change are being felt today and are very severe. So some of these images basically just show some of the impacts that have been happening, and they range from anomalously high temperatures, heat waves, and associated human health harms from that as well. Wildfires that have been pretty terrifying, seeing images from the US and Australia over the past couple of years. Really extreme wildfire events that obviously have impacts for biodiversity as well as humans, and the ability of those forests to actually store carbon as well. On the, I guess, more kind of precipitation side of things, extreme flooding events and storms are also a result of climate change because of that increased energy in the earth. Yeah, more unpredictable storm paths as well. So the key takeaway here is that we're moving from kind of a climate system that is relatively stable to something that is unknown and has more risks and harms associated with it. So obviously, and another thing to note is that all of these kinds of impacts will worsen with the additional amounts of greenhouse gases and warming that we like put into the earth. So in recognition of the issue, there are a number of different, there've been a number of different international political gatherings around the responses to climate change. One of the most significant kind of conferences in the past few years was the Paris Climate Change Agreement, the Paris Climate Conference. And this is one of the meetings of the UNFCCC, so that's the United Nations Framework Convention on Climate Change, which is like an initiative that global nations sign up to limit global warming. And at Paris, what was agreed was that countries would put forward their own determined contributions of how much they would reduce their emissions in a certain amount of time. And these commitments are called nationally determined contributions. So this is a more voluntary basis than was kind of previously discussed in things like the Kyoto Protocol. But it meant that most countries were on board with this, and countries have kind of committed to these reductions at Paris and also in subsequent conferences as well. The other thing to note about Paris is that it was generally agreed that global warming should be limited to no more than 2 degrees, with an ideal target of 1.5 degrees of warming on average. So after this, another important point in international climate politics and national agreements was the IPCC special report on 1.5 degrees of warming, which came out in 2018. And the IPCC is it's a representative of the global scientific community. So loads and loads of scientists from across the world will be part of the IPCC, and they focus on climate impacts and climate trajectories, so how we can get to the place we want to be. So they put this report forward just talking about the differences between what would happen at 2 degrees warming and 1.5 degree warming, and concluding that limiting global warming to 1.5 degrees C should be the absolute limit, and also explaining that the way that we would get to 1.5 degrees C, we wouldn't get there without really far-reaching transitions in our infrastructure, in our industry, and transport. But the main reason why they kind of decided to put this forward with 1.5 degrees C versus 2 is just because the impacts of 1.5 are markedly less than 2 degrees. And we should make all efforts that we can to get to 1.5 instead of 2. So following on from that, the UK's kind of Climate Change Act, the piece of legislation that kind of manages the UK's response to climate change, this was updated to have a more ambitious short-term emissions reduction target than was originally put forward at Paris. We're here now, so this is a graph of emissions in the UK all the way from 1990 and then projecting into 2050. So you can see that we've had up-to-date emissions reductions of about 40%, but our target is to reach 100% reduction of emissions by 2050. And that is a net zero target, so that allows for some removal elsewhere of carbon, acknowledging that with current technologies, it's unlikely that we'll be able to get to absolute zero by then. Scotland, Wales and Ireland, as well as the north of Ireland, have targets as well for net zero. So this is actually slightly out of date now. Wales's 2050 target is 100%, as well as Northern Ireland and Ireland. And then Scotland has a net zero target of 2045. But in response to the calls from the IPCC, the UK kind of made its 2035 target more ambitious. So it's now a 78% reduction by 2035. And this Climate Change Act and the kind of carbon budgets that are put forward that we need to achieve sit above all of the, targets of infrastructure projects and organisations in the built environment. The UK government has a responsibility to reach these targets. So also has a responsibility to encourage different parts of society and the economy to also decarbonize in line with these targets. So that's kind of a bit of a legislative background to why we should set targets, why we should meet targets for decarbonisation. But there are also other benefits that come along with kind of taking concerted action on climate. And these range from, keeping up with legislation that is in the pipeline, reduce risk of energy security. So understanding your energy supply and optimizing that can help you be more resilient to shocks in fuel prices and that kind of thing. It can also help you meet client demands as we're all on a call here, organised by HS2, and HS2 have a strong interest in making sure that their supply chain are carbon literate and are working towards the same carbon reduction targets as the overarching body. So meeting those client demands is also a good benefit of looking at this kind of thing. And winning new work and improving reputation as well. It's only going to get more important to society and to clients that we're working on carbon and reducing carbon emissions. Cool. Does anyone have any questions about the background there that I've just set? We'll go on to some more technical questions now. Jude, do you want to go?
Yeah, I was just curious in relation to the amount of carbon emissions that the UK puts into the atmosphere.
Yeah.
What percentage of that would that be of, let's say, the worldwide percentage of carbon?
That's a really good question. I'm just trying to think. I have another slide with just that being answered.
Okay. Sorry to jump.
But it's not in this deck. No, it's not in this deck. It's in
it's
in our introduction to climate change session. It would be under 10%, I'm going to say.
Okay.
Like countries like the US, China, and India, as countries, not as per person, they would be the highest emitters, and they would be like multiples of the UK's emissions. So historically, I know that places like the US is about a quarter of historical emissions. So yeah, it kind of gets exponentially, like curve is sort of like a bit exponential, and where we'd be somewhere on, around like the 20th biggest emitter or something like that, I would say. But there's a really good website called Our World in Data where you can look at all of these. You can look at emissions across all the different countries and per person and historical. So if you're interested, I'll put that in the chat now.
Sure. It was really a two-part, because if we're sort of 10% of stuff, we've got some really good ideas that we're bringing across. Is there sort of like an international sharing of those sort of ideas and saying to, I don't know, whoever, India, China or whatever, right, this is what we're doing. How about you guys? Do you want to try and do some of this as well?
Yeah, there would be knowledge sharing happening at the UNFCCC level for sure. Yeah. So like the negotiators from different countries and that kind of thing. Those conversations would be being had at the UNFCCC, and then also conversations about actually knowledge sharing, almost as I guess like a fair, like at the fairness angle of that. So both funding, but also giving knowledge to countries that are less responsible and less rich countries as well.
Sure.
So that would be a part of it, but could always be more. Okay. And then I suppose in different like sectors of the economy as well. There would be like international business coalitions around specific strategies, I would imagine. And yeah, that would be going on. Yeah.
Sure. Thanks a lot. Cheers.
Okay, so moving on to like more specific terminology around science-based targets now. This, I'm going to spend a bit of time on this. So this graph shows trajectories of warming and kind of lines that with different scenarios. So these are like modeling projections. These would be created by climate scientists, climate modelers. And when we talk about like science-based targets, we're talking about the science that sits behind these kind of trajectories. So you would have a science-based target to keep warming below 1.5 degrees, or you could have one well below 2 degrees. And that means that you're aligning with this global pathway to meet 1.5. So you can see on the left-hand side here, we've got emissions in billions of tons, so in gigatons of carbon dioxide. So it's a global picture. And then we have time. So you can see here how you would say at 2050, you would have a specific target of emissions at that point in time, and then bringing it more close to us now in 2030, you would say, okay, well, global emissions need to be here at this point in time. So this kind of this is a way of setting targets to get to the ultimate goal. Besides the 1.5 and 2 degrees pathways here, we've got other scenarios that are based on what the global political community is doing. So we've got a pledges and targets line here, the blue line. So this is basically showing you for all of the commitments that countries have made, if they were all achieved, we would end up with a 2.4 degree world by the end of the century. So that just goes to show there's still a lot of work to be done. And then with current policies, so not just pledges, with the actual policies that governments have in place, the line ends up with us at about 2.7 to 3.1 degrees warmer than now. And that's sort of only leveling off emissions by the middle of the century, and then not bringing them down particularly far by end century. So that's a pretty terrifying place to be. 3 degrees. Yeah, the world would not be recognizable. And then without the worst case scenario, no climate policies are achieved, or we basically just continue with where we are now. Then we would get to a very scary, almost 5 degrees of warming by the end of the century. Tessie, you've got a question.
Yeah, just to ask whether or not, when you speak about emissions on that graph, does that include offsetting data?
No, this is just greenhouse gas emissions. So that's a good point. This is why when we get to 2050, most of the time people talk about if you're in line with 1.5 degrees C, you're looking at net zero by 2050. That means you're obviously here, but there is still some emissions at 2050 expected. So that's why there needs to also be an effort to remove carbon at that point. And that's where we get the net zero idea from. Okay, I'll continue. Oh yeah, this bullet point here just goes into what I said. So the idea behind science-based targets is that it takes this kind of picture, which is a global picture, and it aligns it to organization level. And then yeah, net zero, we just mentioned net zero. It aligns with net zero because there are some activities that happen that are difficult to decarbonize with current technologies. So we're talking about net zero in comparison to absolute zero, which would be absolutely no emissions happening at all across society. Net zero gives that little bit of wiggle room just to say we'll need to be removing carbon elsewhere and increase the carbon sinks globally because there's just some things that right now we can't decarbonize. But net zero carbon as a concept, it does have quite stringent caveats to it. So you can't just offset all of your emissions. the idea is that you reduce emissions as much as you possibly can internally and within your supply chain before you, kind of go off and fund any extra removals. So the nets, if your organization or even your country is net zero, the idea is that you've reduced emissions as much as possible. And you're also including the whole value chain of your organization. So not just your organization, but thinking about the materials that you purchase, as well as the use and end use of your product or your asset. That all needs to be decarbonized as much as possible. For many organizations, that, outside of the organization is actually the biggest carbon hotspot. And then, once all emissions have been reduced that are possible, then that can be balanced out with any GHG removals that you can fund or carry out yourself. So the ISO International Standards Organization has produced net zero guidance for organizations. So if you want to kind of know a bit more about that, find out more on what net zero really means, then I would recommend going there. Net zero and carbon neutral are two terms that are often used interchangeably, but they are different. So it's worth being aware of the differences between those. The concept with carbon neutral is basically that you've got net zero without those caveats that I mentioned. You can achieve carbon neutrality by just focusing on scopes 1 and 2, and you're allowed to offset emissions as well, which means that you can fund emissions reduction programs. You don't necessarily even need to be removing the carbon. So that's what carbon neutrality is. I generally would advise organizations to steer clear of using the term carbon neutrality, and just if they want to set a net zero target, to set a net zero target, but primarily to just be transparent about what your actual emissions are that you're focusing on reduction for, and communicating like absolute reductions in percentages. I think that would be the most transparent way of going about things personally. So just following on from what I said there, for your own organization, I would advise careful use of these terms, and also transparency about use of these terms. But when you're dealing with other organizations as well, maybe if you're in procurement, or you're a client looking at supply chain organizations, then when organizations say that these terms, it's worth just asking follow-up questions about what's actually included within those. How much of the value chain is included, how much of that organization's operations are included, and then also how much offsetting they're actually planning on using to achieve that net zero target as well. Because obviously not everybody can offset all of their activities, that we wouldn't have enough finance or land for that to happen. Oh, it's going to take so. All right, so when you're setting a target, you need to kind of have a bit of a grasp of where your emissions are sitting in your organization. And there are a few ways and standards and frameworks that kind of categorize those emissions. So we're going to kind of talk about how that works now. One of the main ways we talk about emissions and how they're categorized is through the language of scopes. And I'm just going to go to our polling software now, so that you can all let me know how much you know about scopes, and absolutely no worries if you know nothing about scopes, that's fine. So if you could all go onto your smartphones, or open this in a separate browser window. If you've not used Menti before, it's just a quick online polling system. So I'll ask you questions through it, and then the answers will show up on the screen for everybody to see. But it is anonymous, so you don't need to be worried about bigging yourself up. I'll just, I can see some people are joining now, but I'll just put the instructions in the chat as well, in case that's easier for people on browsers. So it's menti.com, and the code is 637344743. Lovely, that's great. You can also use the QR code, because we are in the year 2023, and QR codes are all about. So I'm expecting, I'm going to aim for 40 people to be on the Mentimeter. I think I've got 30 at the moment. So those of you who aren't on there yet, get joining. I know it's not always possible for everyone to go on there, but try our best. And if anyone's struggling with that, do let us know in the chat and we'll be able to help you. Okay, cool, nearly there. I'll go on to the first question, and the instructions will stay at the top of the screen, so don't worry if you're not quite there yet. Okay, so the first question is, do you know your scopes? Do you know what scopes are? Yes, maybe, no, or haven't got a clue what I'm talking about. Thanks for being honest. That's absolutely fine. I can see we've got some people who are familiar with the idea in the audience as well. So hopefully you won't mind having a quick refresher. Okey-doke, fab, thanks for that. I'll just go back to my slides and we'll just go over them for those of you who need a bit of a refresh or you haven't heard of scopes before. So what scopes are is a way of categorizing emissions. They were kind of included for the first time within the GHG protocol. So the GHG protocol, if you haven't heard of that, is basically the Bible of how you do carbon footprinting. So how you organize your carbon emissions. It's applicable to countries and to organizations. So if you're doing a carbon footprinting exercise, you're trying to understand your emissions, you would use the GHG protocol to be in line with everybody else, basically. So GHG protocol have these scopes within them, and it's a way of thinking about your activities as a company and also your value chain, what emits carbon within your value chain and how we can categorize that. So there are scopes, but there's also this terminology of direct and indirect emissions, which are related. Direct emissions are just coming from sources that you own or control. So they're things like your company vehicles, gas boilers in your company facilities, any leakage from like HVAC equipment that might be putting greenhouse gases into the atmosphere that's in your facilities as well. And also if you have any chemical processes that release carbon dioxide or any other gases that are greenhouse gases, then you would also have that as direct emissions. So it doesn't cover that wider range of different emission sources, and it's just ones that you control as an organization. The other way of saying direct emissions is scope 1. So scope 1 and direct emissions mean the same thing. They're just things that happen in your own operations. Indirect emissions cover both scope 2 and 3. These are classed as emissions that you're not actually directly releasing, but they're happening as a result of your activities. And they're split into scope 2 and 3. So scope 2 is a very small kind of section. It might be a hotspot, but it's just one type of activity, and that is the electricity or steam or heating and cooling that you purchase from an energy provider and use in your own operations. So it's it sounds like a little bit like a direct emission, and I understand if that's confusing, but because the electricity or the power is actually being generated by a different organization, so you know your energy provider, and you're purchasing it, it is classed as indirect, and it's put in its special box called scope 2. And then scope 3 emissions are all the other indirect emissions that happen both upstream of your organization and downstream of your organization. And they can cover a whole range of different activities. Some of the most common ones that people would include are things like employee commuting or business travel. So that is happening as a direct result of your organization, but you don't actually own the vehicles that it's happening in. Things like waste generated. So that is ultimately the responsibility of the waste contractor that you have, but it is an emission from your activities or the handling of the waste and disposal of waste. And then things like purchased goods and services. So for HS2, as we said, a massive hotspot in their carbon footprint is the materials that are purchased and are used to build the infrastructure. So that is an important scope 3 footprint. On the downstream side of things, in the HS2 infrastructure context, that would be the use of the energy that's used by the trains on the network, which, as we've discussed, are aiming to be zero carbon. I can see we've got a couple of questions about this, so I'll just take a bit of time on those. Isaac, did you want to let me know what your question was?
Yes. Hello, can you hear me?
Yep.
Yeah, thank you. My question is all about the scopes. Honestly speaking, they are a bit confusing. In the way that obviously scope 1, it seems like it's quite interlinked with scope 2. In the way that you say that obviously company facilities. So to run the facilities, we need electricity. So you would think that electricity will go on scope 1, isn't it? But you are saying that it's scope 2 because it's given to you by someone else, which is the electricity provider. But is it the same with the gas as well?
No, so thanks for that question. I think that is one of the main things that comes up when people are grappling with scopes, and it's something that I found hard to grasp at the outset as well when I was learning about this. So gas would be in scope 1 and electricity would be in scope 2. The reason for that is the question is, where are the actual gases coming from? And if you have a gas boiler in your own facility, if you would actually picture like a plume of gas coming from, like a plume of carbon dioxide coming from that activity, that is actually pinpointed to your own operations. Whereas electricity, if you were to try and find out where that gas was actually being released, you would go to the power plant of the energy generator. So although it's used in your facilities, it's not burning, you're not releasing greenhouse gases from the facility, from the activity itself, it's happening somewhere else. But it is put in its own box because of the knowledge that you have more control as an organization around electricity use than you would the other scope 3 emissions. So a lot of reporting mechanisms and things like Science-Based Targets Initiative, they require you to report and set a target for your scope 1 and 2, and that's acknowledging that it's a little bit further away from what you're actually doing yourself, but it is still like ultimately controlled in a big part by yourself. Does that clear things up a little bit?
Yes, just a little bit. I don't know. I know that other people have another question, but I'm just asking the last one. When you are talking about obviously on this subject, when you're talking about waste, and waste on scope 3, like obviously it's debatable, isn't it? Because I'm talking about our business. We work for the construction industry, and we provide washroom, facilities like IPS, cubicles, and all that stuff. And obviously the way we produce things can be changed if we understand that how much waste we are producing by making our cubicles and all that stuff. So which I think that is a direct correlation with the way you operate, isn't it? If you don't have optimal yield, then you're going to produce a lot of waste. But if you obviously you concentrate on that, then you will be able to reduce your waste, by having biomass boiler for the off-cut and all that stuff. So my question is, why is it on scope 3, which is indirect, and I believe it obviously is direct impact from your business, isn't it, the waste that you produce? So if you can give a bit of clarity on that, please.
Yeah, no, of course. I mean, I think one thing to mention is that like scope 3 is definitely not it's like recognized as being important, and that covers all the different activities within scope 3. So just because it's called indirect doesn't mean it's not important and something that should be focused on, but it's just so it's put in there just so that it's clear who at the very basic level owns the emissions, and the waste company that is dealing with the waste would be the ultimate kind of controller of what happens to it. But it would be one of the first things that I would expect organizations to report on and be acting on. So it's a categorization system, so kind of decisions had to be made, I guess, with the GHG protocol and where things went. But I don't think that should put people off from taking scope 3 really seriously and kind of understanding your own organization and where your impact can be, and then setting targets appropriately.
Thank you, Naomi.
Thanks. Right, let's see who else has got their hand up. Jack Wang.
Hi,
Hello. I think you just went off mute, on mute and off mute.
oh, sorry. I think my question really is in scope 3, because how do we ensure that we're not double counting? Because if we are counting upstream and downstream activities in terms of transport to us for the goods that we need and then transport on, how is that not then being double counted? Because the company that's then transporting them to us is also counting that. And so are we not creating false data at a sort of national scale if all the companies are counting the same things twice effectively?
Yeah, no, thanks for asking. Yeah, that's another like key thing that that comes up a lot as well, because I totally understand what you mean. And yes, you would be double counting if you were to add up all of the scope 1, 2, and 3 emissions of everybody in the value chain. You would end up with a figure that was not correct. It would be a lot more than the actual emissions that were happening. But I think that's one of the main reasons why the GHG protocol set up this scope system, and that's because scope 3 is acknowledged as being the responsibility of multiple different organizations. So everybody like who uses the GHG protocol is accepting that scope 3 emissions are going to be the scope 1 emissions or the scope 2 emissions of another organization. But the fact that they're categorized in that way means that we know that nobody's scope 1 emissions are going to be double counted. And if we exclude the power generation sector, we know nobody's scope 2 emissions are going to be double counted as well. So that is kind of, it's recognized within the system that that situation would arise, but categorizing them in this way helps clarify that. In terms of kind of scaling that up and looking at, you know, the emissions of a sector or the emissions of, say, a nation, they're normally not done from a bottom-up approach. So they're not normally aggregating organizations scope 1, 2, and 3 emissions from that level. It would be looking at the emissions intensity of certain sectors of the economy and doing like an economic analysis from the top down.
Okay, so does that mean that we should still continue to get that information, but we get it from our partners who provide those goods or who we then send on to, so that we don't make a calculation and end up having two slightly different sets? Is that what we should be doing then?
It depends on what's available and then what's feasible within the ability of your organization. So to collect things like scope 3 data, there are different kind of levels of like accuracy that is totally acceptable to have. You would just want to be clear about what method you're using. So you might not be able to go out to all of your material suppliers and get their apportioned like energy use information for that particular product from all of them. So you might need to use things like databases that are available online. I think someone's sharing their screen that isn't me. I've never seen that before. Can you still see my screen? I'm just going to reshare.
No, we can't.
Okay, great. So where's my Teams gone now? Yes, so there's different levels of kind of accuracy you can use. You could just say, okay, we buy 10 tons of concrete, so I'm going to use the average factor for the emissions intensity of concrete, and I'm going to work out what my scope 3 emissions are in that way. And that's fine. It doesn't matter if that's slightly different from a supplier. But if you want a really accurate picture of your scope 3 emissions, then you would need to speak directly to your suppliers, and also on the other side of things, your end users. But yeah, organizations can estimate their scope 3 emissions without going to suppliers if that's the best way of getting a quick overview. Yeah, you just need to be transparent.
Thank you.
Greg.
Yes, hi. This is a little bit of a follow-up question from the one just asked.
Mm-hmm.
In terms of the suppliers, let's say I've got one of my supplier that provides data and a proof that their emissions have been offset it, so to speak. And let's say they can certify that in a way. Can I then take that and exclude it from my scope 3, since I have a sort of valid certificate, or somebody confirming, some organization confirming that this supplier is offsetting their emissions?
That's a really good question. I think I guess it like could depends on that question. Like, could you do that? Is sort of a, I don't know, it's sort of an abstract thing. It depends, like it kind of depends on what your goal of your carbon footprinting exercise is, and also like whether you're using that in service of a reductions target, like a science-based target. Because within a science-based target reduction plan, you wouldn't be able to include offsetting. Within that, it doesn't allow you to include offsetting. You have to just say this is an absolute reduction target. So say if you want to set a science-based target and then you want to work towards that, then if in that situation you would need to get the emissions of the company that was a supplier to you without the offsetting involved. And I think generally the overall goal should be to reduce emissions across the board as much as possible before using offsetting. So I'd be wary of kind of going into that space. I think if you're going to have a transparent and honest and robust carbon footprint, and then following on from that robust target, then it would be more sensible to just kind of go with the actual emissions rather than including offsets.
Okay.
I think the
Makes
greenhouse
sense.
gas protocol probably has more detail on that as well. So yeah, maybe check that out from info.
Okay, thank you.
Okay, cool. I think I'll move on. There are a couple of more double counting questions. How do we prevent double counting of carbon? Just report according to the greenhouse gas protocol, and then you're good. If there's situations like leasing situations where you're just like hiring out vehicles and things like that, there is more detail about how to deal with those specific scenarios in the GHG protocol, and it is relatively like accessible language. I don't be put off by the fact that it sounds really like big and important. So yeah, I think I'll continue on. But just to say as well that we do have the Supply Chain Sustainability School periodically runs scope busting webinars. So we have an extended webinar about scopes that you could, if you want to refresh what I've said today or just go into more detail, then you could book onto that for free. So just keep an eye out for those. Okay. Another framework that has been mentioned already today, which helps to kind of organize the carbon management process, is PAS 2080. So this is a standard about carbon management and infrastructure projects. And I know HS2 is accredited and also kind of requesting accreditation for partners to PAS 2080 so that everybody can report in a common language. So yeah, that can be used. It's applicable to anyone in the delivery of infrastructure, and organizations can be validated against this. Dal showed this diagram earlier, but this is kind of just laying out the process of PAS 2080, and it kind of just goes along. It includes all of the work stages of infrastructure delivery, and then throughout the process, there's a target setting, baselining, and monitoring approach. And then the reporting goes into quantification of emissions for the project's infrastructure asset. And then carbon reduction actions can be informed by that quantification of emissions. And then you can kind of cycle through that continuously throughout the project. So within PAS 2080 guidance, there's specific requirements for different kind of roles within the value chain. So there's specific guidance for asset owners, designers, constructors, and product or material suppliers. So I won't go too much more into this, but just be aware, and you can find out more about this online. There's also going to be a new version of PAS 2080 launching very soon. I believe you can sign up to that launch on the BSI group's website. It's on the 5th of April, if you want to find out about that and understand the updates. One more thing on PAS 2080 is that it organises the life cycle of a infrastructure project into specific kind of sections. And this is to so that people can speak a common language and explain where emissions are coming from within the whole life cycle. This ties into other standards as well. So everything's kind of a common language, as I said. The infrastructure sector has additional user carbon areas of the life cycle. So just recognizing the importance of the emissions that come from people actually using the infrastructure. That's included in the in-use phase of the project. But throughout here, there's a lot of embodied carbon that's produced. And then, yeah, operational carbon would be slightly separate to that, but still important. Have we got another hand up, or is it from before? Cool. I think it's a good time to probably take a quick break. I will just give you guys a 5-minute break if that's okay, because there's a bit more to get through. So if you could come back to the workshop at, I'm going to say 5 past, sorry, I literally am so bad at time, 11:15. That would be ideal. And then we'll go through the Science-Based Targets Initiative in the second half. Okay, so thanks for sticking with me for this bit, and I'll be back with you at 15:15. Thanks. Hey everyone, I'm gonna continue on now, so hopefully you're all back from your breaks. Bear with me, I'll just share my screen again. Okay, so we're going to get on to science-based targets now, and I'm just going to go through kind of some of the main ways that you can set one, and also the key requirements for setting a science-based target within the Science-Based Targets Initiative. So first of all, we're going to do a quick Menti exercise again, just asking what the nature of your business is in terms of size and whether you have a science-based target already. So I'll just go back to the Menti here. So this is just a simple questionnaire. So just fill in your organization size if you can. Thanks for that. Okay, so we've got a bit of a spread. The reason why this is relevant is just because there's a slightly different process for setting a science-based target depending on your organization size. No. If you're just going back from the break, we're just going back to the Menti for a sec. Just going through some quick questions to set the scene for SBTI. Okay, I'll move on to the next question. It's good to know we've got some small organisations in the room, so that'll become relevant later. And do you have a science-based target? So does the organisation have one already? Are you working on it? You're not sure, or you don't have one yet? Okay, good to see that people are kind of getting involved with the process. I guess the initial stage of setting a science-based target is collecting data on your carbon footprint. So that might be where a lot of people are at this point in time. And good to see that some of you already have a science-based target as well. Yeah. Okay, so just to set the scene a bit about the SBTI, the idea of the Science-Based Targets Initiative is that it's a method for any organisation. Within reason, there are some organisation types that can't set science-based targets, but most organisation types can set science-based targets. But the idea is that it's going to be in line with the Paris Agreement goals of limiting warming to well below 2 degrees and making the best efforts to limit warming to no more than 1.5 degrees. And then another kind of benefit, I suppose, of setting a science-based target is that you kind of are listed amongst other ambitious organisations to drive climate action, but also through the process, you'll be identifying opportunities to reduce your carbon footprint and associated cost savings within that, as well as kind of being able to be really transparent and reporting your footprint to your clients and getting all those other benefits about, preempting legislation and having a good reputation amongst society. It's basically a partnership between a number of different NGOs and the UN Global Compact as well. So to set a science-based target, there's two different routes. One is if you're an SME. So this is the process for if you're an SME, and that's defined by the SBTI as having fewer than 500 employees. So you might be classed as an SME by the SBTI, but not for other reporting mechanisms like SECA and ESOS, just to be aware. And the process for SMEs is that you would, prior to day one here, it's assuming that you already have a baseline and a carbon footprint made. So just as a caveat, you need to do a carbon footprint. And then you need to submit your target setting letter to the SBTI. Then you make a payment and the company's target is published on the website. And then after the approval, you can then report your inventory and progress against the target on an annual basis. The idea around, I'll go into a bit more detail on how you actually set your target in a minute, because it's the same process for both SMEs and large organizations. But the differences with SMEs is that you pay less, and you also have a streamlined process. There isn't a sort of more lengthy verification process that the SBTI carry out. Yeah, as I said, it's a special quicker route for SMEs. Basically, the SME would be setting a target for scope 1 and 2 emissions, and you have to choose the temperature pathway. I believe that SMEs can set a well below 2 degrees pathway, but if you want to set a net zero target, you have to set a 1.5 degrees pathway. And that could, so you could set a short-term or a long-term one, including a short-term target. And yeah, yes, oh my gosh, losing my voice. The SME defines the state of net zero as reducing a state of no impact on the climate, and it implies that you are achieving a scale consistent with global net zero pathways, so reducing emissions as much as possible, and then you're able to kind of neutralize any remaining emissions using removals. But as I said before, you can't include offsets within your progress to targets or your targets. In terms of scope 3 emissions for SMEs, the SBTI wouldn't approve. You can set a scope 3 target, but the SBTI wouldn't approve that, just because that would require more of a lengthy process of validation. But you do have to commit to measuring your scope 3 emissions as an SME if you want to be validated. And yeah, as I said, you have to report on an annual basis, and that can be through existing mechanisms that you have for reporting, or just in your annual reports or sustainability reports that you would publish online. And then to set a target, the form for that is available at this link on the slides, which you'll be shared after the session. And the cost of this process is $1,000 for SMEs. So for large organizations, as I said, this would be over 500 employees. And it's a similar idea where you're committing a target that you've created based on the carbon footprint that you have and the target year that you've chosen. These interim steps are kind of additional for large organizations. So you have to be verified and validated by the SBTI to be in line with their criteria. And that the whole process between committing and actually being verified and publishing your like the fact that you're verified on the SBTI website can take like 2 years, so 24 months. But yeah, again, the same process with SMEs that you would have to then report progress annually. So the criteria for developing a target is included in a number of documents that are freely available on the SBTI website. But I'll just go through some of the kind of more technical aspects of this now, and you'll have these slides obviously, so don't worry about reading everything now. So for boundaries, the company has to include at least 95% of scope 1 and 2 GHG emissions. And you also, within the scope 2 emissions there, you have to state whether you're using location-based accounting or market-based accounting. This is explained more within the GHG protocol, but it basically means whether you're using the grid value of electricity emissions intensity, or if you're using an amount supplied by your energy supplier. So say if you have a green tariff, then your electricity supplier might say this is 0 tons of carbon dioxide equivalent energy, like per kilowatt hour, and you can use that, but you just have to state that you're doing that. In terms of scope 3, there's a few percentages in here, so I'll try and get them right, but to set a science-based target, you have to do a scope 3 screening exercise. So you don't need to know exactly what your scope 3 emissions are, but you have to make an effort to understand them. So you can do this like based on spend. or by using average emissions factors for materials. But you have to basically understand how much of your scope 3 accounts for as a percentage of your overall your overall scope 1, 2, and 3 emissions. If it's more than 40% attributed to scope 3, so if you have a significant emissions footprint within your supply chain or your or downstream of your operations, then you would need to include at least 67% of the scope 3 emissions in your in a target for reduction. Which, so yeah, basically 2/3. So yeah, that's the scope 3 situation. I don't think fossil fuels sales sector is relevant here. Yeah, this kind of avoided reducing carbon credits, offsets or removals cannot be counted for with SBTI. That is important to note. So even if you are purchasing offsetting credits to which have got you to your baseline, or you aim to use them to get to your target, you can't include them within your target. It has to be absolute emissions reductions only. So it doesn't mean you can't use them, you just can't include them. Yeah, we've got a question.
Sorry, yes, another one. I have a question in terms of growth of the company compared with this, because we are obviously endeavouring to reduce our emissions, but we are having growth of, luckily, I appreciate, over 20% per annum. So as a consequence of that, our headcount is obviously considerably bigger. Our business mileage is bigger because we've got more people doing travel. We've got more scope 1 actual vans going out and about, etc., etc. Is there anywhere within the SBTI that we can kind of caveat or bear it in mind that that growth will impact it? Because if you've got 200 headcount, which we had in 2017, compared with 778 we have now, and we've had we're now 5 times the size or 4 times the size we were then. Is there anything to bear that in mind, or not? Or because if it's absolute, we're only going to look like we're increasing, but we're trying to decrease sort of on a per person or per turnover million, if that makes sense.
No, that does make sense. And I think I've had this question before, kind of in the context of like startup organizations and that kind of thing. I think in this case, I don't know if you could avoid that situation, because it does need to be an absolute reduction target for most organizations. There are some sectors of the economy that the SBTI allow to set intensity targets. So, but for most organizations, you could set an intensity target, like you say, per turnover, but it would have to be as well as your absolute reduction target. I think I would recommend just going onto the website and going to the FAQs in that regard, because I think it might depend on the type of organization you have, and there would be more information on there. But I think you would need to just kind of account for that. If there is a significant change in the organization, say if you have a merger or something like that, you take over another organization as well, then that would class as a significant change within the organization that would require you to reset your target. So you'd have to reset your baseline based on like the change, and then set a new target following on from that. But I think in this case of like gradual growth, that wouldn't account for this. So yes, I don't feel like I can give you an 100% solid answer on that. So I would recommend going to the FAQ part of that of the SBTI website, if that's okay.
Okay, thank you.
Thanks. There's some more criteria here, so I'm going to go through that now. The ambition for minimizing temperature rise. So what this is a question about what your target is actually in service of. What emissions pathway is your target following? So for the new version of the SBTI criteria, which came out in July last year, for scopes 1 and 2, you have to be aligned with the 1.5 degrees trajectory. And for scope 3, it has to be aligned to the well below 2 degrees warming trajectory. So the 1.5 one is the more ambitious one of the two here. And this has increased in ambition since the previous version of the SBTI criteria. So in terms of like more additional context around the process, you need to gather data for the baseline year. So you need to select a year where you have relatively good data for your carbon footprint and choose that as your baseline. And then your target is a percentage reduction from that baseline. And there's some kind of year criteria here for when that can actually be. It needs to be like reasonably like a few years ago, but it can't be too long ago, if that makes sense. So yeah, there's more detail on that on the website as well. And then the timeframes of the actual target have to be between 5 to 10 years into the future, basically to just recognise that rapid decarbonisation needs to happen, and we can't leave everything till 2050. So in terms of progress, to remain kind of verified by the SBTi, you need to be meeting the ambitions, and you need to kind of report on those. So communicate, disclose, and recalculate. The recalculation here is what I mean when I was talking about like mergers or divestments within the organisation. If there's significant change in your organisation structure or function, then you would need to recalculate what your target is, and that also has to happen automatically every 5 years anyway. There's also a requirement to develop an action plan for how you're actually going to meet the target, but that is not assessed by the SBTi just because it varies from organisation to organisation. And the charge for large organisations is $9,500, so more than the small, but still not a crazy amount of money, I would say. This image here shows you, quite pixelated, but it shows you the tool that you use to actually set a target. And this is available online, so you can go and play around with this, like even if you're not in the position where you can set a target yet, just to see how things look. The link's on the screen. I think I've got it open here actually. So this is what you download. Ignore the grey bit. You can see here that just in order to actually set the target, you do this as an organisation. You just have to input some fields. So you have to input the base year that you choose, which is the first year the year you're going to use to have percentage reductions from. So you set the base year, you set the emissions for that base year, and then you choose a target year, which has to be near term, as I said. So I've chosen 2030 here. Then you have to input the emissions for your most recent year, just to help the trajectory be more accurate. So I've put these figures in, which are just off the top of my head. And this is the sort of graph that comes out of that. So my emissions at the baseline are here, scope 1 and 2. And then there's sort of a percentage reduction year on year that follows the 1.5 degree trajectory for Paris Agreement. And where it comes out at in 2030 are these blobs. So that's the emissions that I'm not allowed to exceed by 2030 for scope 1 and for scope 2. And then it gives you a percentage reduction by that target year here as well. So it adds up your scope 1 and 2, and mine is 45%. So I would then go and communicate my organisation is going to reduce emissions by 44 or 45% by 2030. And that's what you would submit in your target setting letter to the SBTi. Have I got any more on this? Okay, cool. So this just shows a bit more about scope 1 and 2. This is the absolute reduction target here for 1.5. You would essentially be coming out with a 4.2 linear annual reduction rate. And for scope 3, because it has to be well below 2 degrees, it will be a bit less per year. If you want to set a physical intensity reduction target, so like per floor area or per turnover, you would use a different tool, but this tool is only available for certain like organisation types. So I know like intensive materials manufacturers would sit within the ability of setting physical intensity reduction targets, and some agricultural or food retail businesses would be able to do this as well. But for most people, for most organizations, you'd have to just set an absolute reduction target. So if you're unsure, just go to the website and just check up on that. Okay, I think we're getting towards the end of this bit. This section, this just goes to kind of illustrate the process again, but it's the same as the previous slide. So submission, validation, communication, and disclosure is the process. And the hardest part of, I think I've heard from many organizations that the hardest part of the process for setting an SBTI is like right at the start, when you're actually trying to figure out where your baseline is, you're getting all your data together. That can be the most challenging part. And then once you're reporting on an annual basis and those processes are in place, then it gets easier. I guess then the difficult part is actually reducing the emissions. But there's a number of different activities that you can do to do that. This shows you the relationship between a long-term and a short-term or near-term science-based target. So as I said, the Science-Based Targets Initiative encourages 5 to 10 year reduction targets to be set. You can also set a net zero target, which generally would be up to 2050. But you can't set a net zero target without setting a near-term science-based target for the SBTI. And this is sort of like a suggested emissions pathway that you would be following. So your target here would just be on the pathway to net zero there. Okay, that's the end of my science-based targets info. So let's go to questions again. What's the benefit of being validated by SBTI? Basically, the fact that it's third-party accredited, and it's sort of like I would just say a badge of, I don't know, the same way that you would like align to any international standard, or just because it's agreed as a kind of robust process, and it's a badge of saying our target is robust, versus, and we're also, if it's a net zero target, it's also the highest standard of net zero target that there could be, because as I said earlier, there's a lot of different claims that are made around net zero and carbon neutrality. So I'd say that the fact that it's a common process is useful, and there's also the commercial benefits that I described earlier as well. Debbie, what's the average timescale for process if you already have a baseline? I think it would be that 24 month process, but maybe organizations who have gone through the process, if they're large, can maybe respond from their experience to Debbie in the chat. John, I've heard that the SBTI now demands land use change emission targets for many sectors. Do you know anything about this? So that would be things like agriculture. I know the SBTI are working on their like FLAG guidance, which is like the food, land use, agriculture guidance. But personally, I don't know too much about that. Sorry, you need to go to SBTI run session or read their own materials, I think. Okay, for small design companies like ours, does this miss that where the real impact can be made, which is around producing innovative designs that drastically reduce construction-related carbon? I think that's a really good question, and I think where you can kind of bring in that opportunity is by making sure that you're sort of getting an understanding of the impacts of your designs on the carbon in use of the asset that you're designing, or the building that you're designing, and incorporating that within your scope 3 emissions. If one of your carbon hotspots is use of the asset that you're creating, and also the embodied carbon within that, then that would be included within your scope 3, and you can kind of include that within your target setting. I don't think there would be anything excluding that from being included, and in your carbon strategy that you put out that ties into the target setting, you can be explicit about your contributions towards designing out carbon. I think that is done by design companies and architecture practices. Isaac?
Thank you for the presentation, Naomi. My question is going about the setting of the targets and collecting the data, which is something that I'm doing now. My issue that I have is the fact that I can't find any tool that can help me to convert miles into kilograms, CO2 kilograms, or kilowatt into,
really? Okay.
So I don't know if you have any suggestion for that, so that I can have obviously the right measure.
And what's the mile? Is that from your? So it's like mileage just in your vehicles?
Yes, yeah, mileage from our vans that do the deliveries, and the other kilowatt from the electricity, which is obviously scope 2, is enough scope just from our electricity that we use.
Yeah. Okay.
Per hour as well. Obviously to translate that into the CO2 kilogram emission. That I can't find any tool for that. I don't know if you have any suggestion on that, because I've tried to use the tool that's the Sustainability School is giving for free, which is a sustainability tool, but I don't really get it, honestly speaking.
Okay. No worries. So I would point to the carbon tool, or the carbon calculator, but if you are struggling to use that, maybe drop me an email and I can arrange for somebody to speak to you about it. But if you want, there are actually also loads of other tools, and there are also databases of emissions factors. So what you want is an emissions factor that can convert. Yeah. So there's a DEFRA, the Department for, I can't remember the acronym. They release carbon factors every year. So there's actually a spreadsheet that you can access for free online, which is linked on my resources slide for this presentation, which you'll get at the end. And that actually lists out the different conversion factors for things like different types of fuel that would be available and the grid electricity. So even if you don't use like an online tool, you can just take your activity data and use a basic spreadsheet and put that in there. So
that's what I'm doing. Yeah, actually.
Yeah. So do you get that from DEFRA?
It
would be, it's the first link on the resources slide.
Thank you very much for that.
No worries. Righto, I'm going to hand back over to Daryl now, actually, just to go through what's going on with carbon at Euston. I'll just share my screen again. Is that okay? You can see that?
Yeah, I can see that.
Fab. So just talking about how we can reduce carbon. I'll hand over.
Thank you. So this is looking at how some practical examples of what we've done at Euston Station to reduce our carbon footprint. If you go to the next slide.
I'll go on to the next slide, shall I?
Yeah, thank you. So these are the main kind of requirements that HS2 pass on to their contractors in relation to carbon management. So compliance with PAS 2080 that Naomi was talking about earlier, the requirement to reduce carbon emissions, and then looking at opportunities and also reporting carbon emissions using the life cycle assessment that Naomi went through earlier as well. If you can go to the next slide, please. And so the requirement for our HS2 phase 1 stations is to reduce their carbon emissions by 50% relative to a baseline. And as I said earlier, the assessment is done over a 120-year design life. Next slide, please. Next slide. I think we've been through the LCA stages. And this is, so the Euston Integrated Project Team, we have a series of ambitions, and this is just highlighting that carbon is one of the 4 kind of overarching strategic ambitions for us. So we do take it very seriously. Next slide, please. And next one as well, sorry. So the baseline life cycle assessment report showed that most of our emissions are in 2 kind of areas. So I probably should have put exactly what each kind of life cycle stage is, but A1 to A5 is essentially associated with construction. So you can see that 50% exactly of our projected emissions in the baseline were associated with construction, so material usage and the actual process of construction. And then B6 is the operational emissions, and that was, at the time this baseline was done, we assumed just kind of standard processes to be used. So we assumed that we'd have gas-fired electricity and also heating as well. We've gone on to significantly reduce that by committing to using or designing in the use of renewable energy, and also minimizing the requirement for heating, etc., using ground source heat pumps, air source heat pumps. So we've significantly reduced the B6 emissions. If you go next slide, please. And this is the waterfall diagram showing our reduction over time. So the blue bar on the left is the baseline emissions. So that's 710,000 tons of carbon equivalent. We've managed to reduce that by 41% to 416,000 tons. And we've done that through a variety of mechanisms. I won't go into the kind of specifics, but this has happened over several years of design. So designing, operational emissions, that was a major reduction, and kind of changing the design of our station to make it smaller, more carbon efficient. There's been a range of things. Next slide, please. But we still have, so we're at a 41% reduction, and we've kind of made the easy gains, but we still have a 9% reduction to go to hit our 50% reduction target. So the specifics of this slide aren't important, but essentially it talks about the process. We've gone to set a strategy to achieve the extra 9% reduction. So we look at each life cycle stage, so A1 to A3, A4, A5, B4 and B5 and B6, so different, so construction, the refurb during operation and operational energy. And we've kind of picked out, we have a whole list of opportunities, hundreds of opportunities through design and operation, and we've picked out kind of the ones that are most achievable and will offer the biggest reduction. And we've come up with 7 projects to work on. If you go to the next slide, please. So these are the projects that we're working on to hopefully move us towards the 9% reduction. So we're looking at achieving diesel-free sites and a renewable source of supply to the sites. So I work on Euston Station. It's right in the middle of London, so we're obviously able to get mains electricity in it. And then we're looking at different technologies to power our various site plants and and any generators that we have on site. So point number 2 is looking at different concrete mixes. You'll recall that a massive source of carbon emissions within the construction sector is through materials usage. So concrete is a big contributor to that. Point 3 is looking at our MEP equipment. So the plant that we use for electricity, heating, that sort of thing. When you look at it over 120-year design life, it actually amounts to, and you obviously have to replace the whatever plant that you have, or things get refurbished, it actually adds up to quite a significant contributor to our whole life carbon emissions. So we're looking at maybe different ways where you can rent equipment or service the equipment in such a way that you extend the design life, just to reduce the amount of wastage, basically. The The fourth strategy is looking at HGVs and vehicles coming to and from the site, and whether we can source an amount of, electric powered vehicles or different types of vehicles which have lower emissions. Point 5 is looking at structural design efficiencies, and point 6 as well, the design optimization. I won't go into that. I've got an example at the end there. And then point 7 is looking at setting carbon targets for different work packages. So we're designing and building a station that's broken up into a number of work packages. For example, the piling work, the MEP supply, those types of things. Each one of those sub packages, we're trialing out a different contractual clause for them. It's called the X29 clause, and it was only released, I think, mid last year, and it's an NEC4 contract, I think. And so it looks at setting a carbon target for each one of these sub packages. So the piling for Euston Station is fairly significant. So we've set a carbon target for that, and then the person awarded that contract will then need to reduce their carbon, much in the same way I was talking about earlier, against a baseline. And then there'll be sort of contractual incentives to do that, and reporting requirements as well. Next slide, please. So each one of those projects that I just talked about, they're a standalone project. They have senior leadership team sponsorship, and there's workshops set up to kind of progress each one of those and report back. Next slide, please. So should we achieve all of our should we be able to realize all of the opportunities and work through each one of the strategies that I've just outlined? We're looking at achieving probably a 46% reduction against our baseline, which is slightly short of the 50%. So we're still looking further at what we can do. There's a number of discussions ongoing, but I'm just kind of highlighting the difficulty once you achieve the early wins of hitting the kind of final 50% reduction. Next slide, please. And this slide is just going into a bit more detail about how we've kind of changed our design. So we're designing a station. It's kind of the structure under the blue line on the left diagram there. And we've also got oversight development that will be built around the station by another contractor. So we're looking at even installing different types of windows at the top of the structure. So we're looking at the difference between double glaze and single glaze windows for the vertical facade on top of the station. And it has a significant impact in both the embodied carbon associated with those two different products, but also the thermal efficiency of the station. So if we install the single glazing, we achieve a lower efficiency, thermal efficiency standard, but we obviously have a much lower embodied carbon. So we're looking at how we can progress this and challenge standards within HS2 and within the construction industry to achieve this, but also hopefully maintain a comfortable and usable station environment for Euston Station. I've kind of flown through that given the amount of time that we have, but hopefully it gives kind of a flavor of the kind of challenges that we're facing and how we're dealing with those on Euston Station contract.
Great, thanks, Sarah. Okay, well, I'll just go through the last few slides that I have, and then we'll take one more batch of questions at the end. I'm just gonna skip through that, Minty, and just cover off a little bit about where you get your data from in order to set a baseline, in order to then set a target in the last couple of minutes. So there are a number of different types of data that you need to collect across scope 1, 2, and 3. In scope 3, obviously materials and products being a big one, and logistics that are in vehicles that aren't your own. There can be challenges associated with collecting scope 3 data, but as I said earlier, there are various levels of accuracy that you can use, which is fine as long as you are transparent. And then, you know, with continual improvement, you can get more accurate as you go along. These types of data can come from different, come within different units, and you need to just make sure when you're doing your footprint that the kinds of data are in the, like, they're converted into the correct unit. So say from pounds spent on diesel to litres of diesel. And then this data can be collected from a number of different sources, which means that you need to communicate with people effectively, set a decent amount of time frame, I guess, is another important takeaway from some activities I've done, giving people a good prior warning that you're going to be expecting some of this data before actually going about collecting it is also a great idea. Then I'm going to show you this, which is what I'll send around, which is the resources that I mentioned. So there's 2 sources of conversion factors here. The top one is for things like energy use and fuel. The second one is for materials, for embodied carbon data for materials, and they're both freely available. And then there are a number of different kind of carbon calculator tools that you can use both for, I guess, your operations and also in design. There's a design Revit connected tool at the bottom there that you can use to check out embodied carbon emissions for different designs. Okay, so we've got 3 minutes left, so let me know if you've got any questions at this point. And then also it'd be really great if we can have your feedback for this session. We'll be running another session, I believe, for HS2 in the future. And also we have a number of different sessions on carbon that are just kind of open to everybody that the school run throughout the year. We have more focused sessions around carbon reduction, designing out carbon, and, you know, the basic kind of scopes and climate change webinars as well. So do keep an eye out on the school website. Jenny, do you have a feedback form? Are you still there? Yeah, we'll share the presentation slides after.
I'll drop the feedback form into the chat now. 1 second.
Thanks, Jenny. Yeah, and I mean, if anyone does have any final questions for me or Daryl, happy to take those now. Otherwise, if you want to head on, then that's absolutely fine. And thanks so much for joining, and hope you've enjoyed the session. Recording and slides will be shared, yeah. Thanks very much.